All right, might as well get started. So I think this class starts at 8:30, right?
Yeah.
Okay. So I am not Dr. LaFollette. I am Professor Rosen. Dr. LaFollette I don't actually know why he's not here today, but he asked me when we were giving our final for 2168 if I could cover this morning for him, since he has apparently a 4-hour commute this particular morning. He will be here on other days, but I think your lab is canceled for the day because of that stuff. Normally he doesn't do a first day lab, so. What?
Nothing.
It was, but anyway, I'm here to cover for you guys and to show you and to teach you guys the basics of C programming. So this is 1057. Now, there's a couple of things you should know. The first thing is that this class is designed for people with no programming experience whatsoever, as well as people who have some programming experience. So C is basically a super arcane language, but it's not particularly hard. It's arcane because it can really just reach into the really, solid depths of your computer and really just, mess with the memory in there, and it gives you a lot of granular control that you would not otherwise have. This is the book for C. I don't know if it's your textbook, but this is the book for C. Okay, this is essentially. Basically, if you learn C, it's almost certainly, I'd be willing to bet money that this is the textbook he assigns. And it is so ubiquitous that I had a spare copy lying around in my office. It is also not too expensive. I think it's like $40 or something on Amazon. But this is written by two of the people who worked on C. There's not particularly too many editions, right? This is the second edition, and the first edition was like 1988, so it's been out for a while, right? There's none of this new edition being added. I don't know if this is, again, the textbook he's going to use, but honestly, I don't even know if he uses textbooks too much. But this one is the reference, and it's very easy to find. It's called The C Programming Language by Kernighan and Ritchie. Also and it is famous enough in computer science to be known as the K and R book, or just simply the C book. Okay. All right. So you mentioned you have no prior programming experience. What about everybody else? Any prior programming?
Very little.
Very little. None? Very little. Okay. So if you want to get a kind of a glimpse into hacker culture and the idea of how certain things work and the way programmers view various operating systems and stuff. This is a bit outdated, but in the beginning, there was the command line, which is basically an essay by Neil Stephenson, is pretty good. And I say it's an essay, but honestly, the way Neil Stephenson writes, he's a sci-fi author. It's kind of like novel-sized, but there's various interesting bits of it that are pretty interesting. It's free; you can find it online, but it just talks about the way certain programming interfaces work. Okay. So let's see. You're using a Mac. You're using a Mac. Do you have Mac? And you? What? Do you have a Windows computer?
Yeah,
You have a Windows computer. Okay. So with Windows computers, getting a C compiler on your computer, which I'll explain what that is in a second, is kind of the tool that you need for in order to start working. With a Mac, that's pretty easy. You just have to go to the terminal, and I haven't actually messed with it yet, but I think all you have to do is just type GCC, and then it will tell you, hey, we need to install the GNU C compiler. All right. And then you can probably do that at some point, right? And that means opening up, and that literally means going into Finder, searching terminal, right? booting it up, and then typing GCC, and then it will probably tell you, if it doesn't give you an error, which it should give you an error, right? Like this says, hey, GCC, no input tile. If it doesn't do that for you, then it's probably just saying that you need to install. It will come up with Yep, and then so you can do that. What can I see? Yep, so you can go ahead and install that, and it will. You'll need to install the developer tools, okay, for that. If you're on if you're on a Windows machine, and I do. The reason I'm doing this is because I have a tendency to record my lecture, so I'll upload it and send it to Dr. LaFollette. The easiest way to install it is to, I think, is to use Chocolate on Windows, which is a package manager for Windows. So what you end up doing is you install it on Windows and there's a video that shows how to do it. Right, you install this in CMD, paste one of these commands in, either depending on whether you're running command or you're using the command line or PowerShell, and then that's it. And then all you have to do after that is and what this is a package manager, which is basically a program that downloads and updates other programs for you automatically. And it's just, Windows doesn't really have one, so then after that, you just simply do choco install mingw. There's a YouTube video, which you can send out to me. If you have questions on the process or installing it, even though I'm not your professor, I'm more than willing to help. Because, this is generally the most annoying hurdle. And generally, we give you guys a week to figure this stuff out. Except, it's summer, so not really. You don't really have too much of a week. But, okay. And so once you get it on your computer, you can start coding stuff. There's also online compilers. So online C compiler, you can do where you can write some of the basic programs online. Right, here it is. It's just simply making sure that I'm not like DDoSing their server or something. And you can program here online, right, and run it. And yes, that's very tiny. Don't worry. When I program it, will actually be much larger. Or you can even use let's see. I'm getting into a lot of hows or different tools you have, just because you have a lot of tools now available to you. Let's see, Google Cloud. You can even use the Google Cloud platform. They've got something there, and I've only used it once, so I'm not really comfortable with showing it to you. So let's just talk. So now let's actually talk about what is programming. So and before I get into that, I guess I need to talk about what is computer science. So computer science is a bit of a misnomer as far as the entire field is concerned. Computer science is not the study of computers. If you want to remember anything from this first 10 minutes, that's the thing to remember. Computer science is not the study of computers. And computer scientists, I find, are a bit like rabbis in Judaism, which is that basically you can get 3 of them in a room and you'll get 5 opinions on a single question. And if you were to ask all computer scientists what is computer science, you'll get vastly different answers that everybody thinks is the right answer. So the best we can do, I think, is come up with a answer that is not wrong, that everybody agrees is not wrong. And so the not wrong answer to what is computer science that I found is that it is the study of algorithms. Okay? So which of course begs the question is, what is an algorithm, right? So computer science is the study of what can be automated, how can we and how we can automate things. So an algorithm is essentially like a recipe when you're cooking. It is a step-by-step process that has some finite beginning and some finite ending, right? I think I have actually some old lecture slides I can. Oh, actually I don't, because I just reformatted this computer recently. So you have some finite beginning, you have some finite ending, and you have some order of steps that happen one at a time. You say, this happens, then this happens, and so on and so forth, right? The steps are well ordered, okay? So, come on, I start typing that up for you guys. So, right? Whoops, let me increase the size of that. Algorithm. Step by step instructions. They are well ordered, okay? And they are, most importantly, unambiguous. I don't even know if that, unambiguous, which means that basically that there's no ambiguity in the way that we can figure this out. I will, if I tell you basically to reach for that item in real life, there's some ambiguity there, but we hope that basically that through being human, you can figure one thing out or another thing out, right? Right, or through trial and error. Computers really don't like that. You have to, if you're specifying to grab that item, you have to be very specific about what that item is, right? So with that in mind, something to remember about computers, about programming, is that computers are like evil genies. They will grant your every wish exactly as you have phrased it, right? The whole be careful what you wish for. So a lot of times I will type, and even after 10 years or so of programming, if I type something in, I will, think I typed in something correctly, and I can't find the error for the life of me because I'm reading what I want to, but not what I actually wrote. So last part is ends in a finite amount of time. In other words, this will end before the heat death of the universe at some point, right? In other words, the algorithm doesn't really count if it's never going to end. If it tries to compute something that it can't compute, it doesn't really end. So the study of computer science is the study of algorithms. So in other words, what can we build algorithms for? What can we and what can we figure? And so what can we build algorithms for is actually a very interesting question that we typically aren't able to answer until you get to a 4,000 level class called automata theory, which gets into so what can computers actually do with the languages we define for computers? But also, how can we efficiently automate things? And that's where it's really important because, honestly, that's where it comes in. Programming is all about implementing these algorithms in a way that we can automate them. Now, the history of computer science starts out pretty... now, the history of computer science is actually... It's kind of both a young field because we're an offshoot of mathematics, but at the same time, we're pretty old. This guy is the inventor... is basically, Algorithmiti. He's possibly the person to start with. Algorithmi. There we go. Oh, come on. Do I have to put in his full name? I do. Mohammed Ibn Musa al-Khwarizmi. There we go. So he was a Persian mathematician, Persian scholar. His name, al-Khwarizmi, is Latinized as Algorithmiti. And this was during and so he was around, let's see, from 780 to 850. He was around during the Islamic Golden Age, where basically there was a whole lot of math and research going on in Persia. So there was, anyway, he did a whole lot of stuff. He wrote a textbook on arithmetic, as well as, he's considered the founder of algebra. In fact, algebra is named after one of his books, Algebra. So that was the first name of it, which means completion or rejoining. But he also, what he particularly named the thing was he wrote a book on operations that you could do with these newfangled 10-digit numbers that were coming out of India, right? The ones that we use these days. So treatise on Indian numerals. So basically wrote treatises on how to manipulate these things, which eventually became our Arabic numerals that we use today. So eventually his name was Latinized into Algorithmi, and today so that just kind of eventually, flew to eventually being algorithm. Now, as far as computers are concerned, computer didn't used to refer to a machine. It used to refer to a person who would do multiple calculations, right? It was a profession, something that you could do to add up numbers. And then, let's see. So we had a lot of people, but the first programmer, that would probably be Ada Lovelace. There's probably other people, but she's considered to be the first. Augusta Ada King, Countess of Lovelace, and if you notice if you've taken any kind of English, her name Byron. Who is Byron? He was a famous English poet, and basically he was kind of a rakish fellow, and basically he was a huge celebrity at the time. And he was very, very, very adventurous and stuff. And so Ada's mother was like, I don't want you to follow in your father's mad blood, so we are removing anything that kind of has passion from your life. So you are just going to study mathematics. And so all she studied was mathematics, and she became a prodigy of that stuff. And so eventually she met Charles Babbage, who had this proposed mechanical general purpose computer. He proposed basically this computational machine that could basically be programmed to do numbers. And Ada had kind of this, she kind of had this amazing idea. First off, this machine never even got built. Never even got completed. But she said, here's the specifications to the machine. Here's how you can calculate Bernoulli numbers on this machine. She wrote a program to do that, even though the machine hadn't been built, right? Doesn't matter. You can figure it, right? If you've got the instruction set, you can, that we're going to feed into this machine, we can do that. But she figured out that you can use this kind of machine if we encode things such as characters or individual letters as digits. Then we actually can build. Then we can actually use this for not just numbers. We can use this for anything. So she was basically one of the first people to realize that we can use computers for things other than numbers. And as a result, so she solidified as herself as one of the first computer programmers. She was about 100 years ahead of her time. Sadly, she died at a very young age, age 36, from cancer. So, but as far as I understood, it was considered the fate of Byron's at that time to die out at a very young age. So, the next person who's notable in computing was Alan Turing, right? You've probably heard of. You probably saw the Imitation Game at some point. Suffice to say, Alan Turing was not actually as miserable as Benedict Cumberbatch portrayed him. He was actually got along quite well with his fellow team members, but he's known for two things. First, the cryptological bomb, which was basically a machine that broke the Nazi Enigma code. And the second thing was his work in theoretical computer science, which said, hey, let's figure, he figured out basically one of the two primary ways we can mathematically specify what a computer is. And so if we can mathematically specify what it is, we can prove what it does. We can prove what a computer can do and what it can't do. So that was the Turing machine, which simply says, let me go ahead and he says, imagine basically this machine that has this infinite band of ticker tape, right? These tapes, this paper tape with squares in it. And all the machine can do is it goes left and right along the ticker tape, and it can mark a square, or it can unmark a square. That's all it can do. Oh, and it can read a square as well. It can see what's on the square. So believe it or not, that's with that being all you can do, that's all we need for a model for a computer. Instead of having just in our computers these days, instead of having ticker tape, we have a bunch of circuits that turn on and off, and those on and off states are just considered ones and zeros, right? And rather than having just one that we go left and right on, we basically just read these series of bytes, as they're called. So etymology of that, a bit is a binary digit. A byte is 8 binary digits. So binary digit meaning it's 0 or 1, right? A bit, binary digit, 0, 1. Okay. Anyway, sadly, he committed suicide by cyanide because he was chemically castrated for being a homosexual. And because of that, basically because of the bigotry of the time, we basically lost one of the most brilliant minds in computer science at the young age of 42. So anyway, I think that's enough history for you guys, because the story of computers, though, has been from big things that exist in this room, from vacuum tubes, to basically getting to transistors, which shrunk things down magnificently. These days, you can carry around a computer in your pocket, which has more power than what NASA had to send people to the moon. It is astounding how small computers got and how powerful computers have gotten. It is utterly shocking. But languages like C were designed at a time when basically computing power was kind of sparse, right? You didn't have very much of it. And so you wanted to eke out every kind of optimization you could. And now that we have computing power to spare, a lot of serious programs are written in C. Even modern programming languages like Python, which is a particular favorite of mine, if it has to do some heavy number crunching, it uses a library that's been built in C. It uses a tool that's been built in C to do that, so it will communicate with C. So let's go ahead and talk about writing a C program, okay? So building a program basically means that we have to write something in a language that I can kind of understand and that the computer can kind of understand. But the computer, unfortunately, really only understands one thing, zeros and ones. That's all it understands. So what we do is use a tool called a compiler, which is that basically we take the program we write, and that will translate it into a computer, into machine language, something that the computer will understand. So I will start by writing out using Vim. Now, typically, the way that I think Dr. LaFollette shows you guys how to program is to have you connect to a terminal, connect to a server that we have running here, and then program on that server, because the server has everything ready for you guys. So all the things I'm doing over here, you'll be able to see. But let's go ahead and write our first computer program. And it's been a while for me to program in C. You see, I've taught an I teach introduction to computer science courses. I teach the Python course here. And I also have taught a C course, but I've never taught an intro to C course. But never mind about that. It's not actually that bad. So the first thing we do is I'm going to open up a utility called a text editor. When you're programming, you cannot use something like Word to do so. You'll want to use a utility like Vim, although I don't necessarily recommend that. Or Nano will probably be a bit easier for you if you're using a terminal. Using Xcode if you're on a Mac is a pretty good idea. Or downloading the program Notepad++, which can be Notepad++, literally Notepad plus 2 plus signs after that. But I'm going to do it the way that Dr. LaFollette will do it first, and then I'm going to use my own program to do it because I like to automate my things. But Notepad++, over here, that's a pretty good open source tool. Open source meaning that the source code for it, the code that has been used to build that program, was freely released to the entire world so that everybody could look and modify it as they needed. So anyway, Vim is a text editor, and I'm going to say vim hello.c. I'm going to create, which will create a new file called hello.c. Now the .c there tells me that it is a C source code file. Okay, and so I open up and it's got basically nothing in there. So I'll start by typing out, and I had to hit I first in Vim because that would put me in insert mode. So if you can't follow along, that's okay. Really, first thing I have to do is that I have to do what are called the include statements. Include standard io.h. And what that has done is that has, you'll notice two things. That basically as I was typing, the color changed. This is a feature, not a bug, of text editors, is that they do something called syntax highlighting, which is that they color different parts of the code different colors to basically let you know, to represent. And so this over here just colors it to let you know that it's an include statement. So what the heck is this? Standard stdio.h. Well, C is a very, very, very minimalistic language, meaning that we want to tell the program, there's a lot of libraries that are involved in C, but we don't want to load them all into our program. We'll get into more of that later. And the idea here is that we are now just simply saying, I want you C to include the file that does std standard IO. Standard IO, standard input output. In other words, standard getting information from the user and outputting information to the user. .h means the header file, which is basically lets us load up the code. So next thing we do is that we go on to the next line and we create what's called our main function. So we create a new function called main, and we use these curly braces over here. So the parentheses are important, and it being all lowercase is important. It is a programming languages are what we call case sensitive, meaning it cares whether things are uppercase or lowercase. Okay. Now these curly braces indicate what is let us know what is inside what we call the main function. When we run a C program, what's going to happen is that our computer is going to look for what's inside main, and it's going to start there for running our program. So and now what we're going to do, so pretty much every single C program will start out with this, saying, hey, we've got a main function, and this is what goes inside the main function. Now, typically what you do is you use tab or spaces to indent into here. So over here, we're going to call another function called printf, which stands for print format. And what we're going to do is that we're going to put quotation mark, so double quote, HELL, hello, comma, world, exclamation point, and then we're going to put a /n over here, a \n. Right, that's right above your enter key if you're using an American keyboard. And then we're going to use a semicolon. So a lot of things are going on over in this line, but this is the only line that we need to write. Okay? So first off, what is printf? The entire purpose of printf is to print something on our screen. It will print out what is known as a string. So a string is what is text in computer science, right? So what is a string? Well, it's denoted between what goes in between two quotation marks. So notice that we have this quotation mark over here and this quotation mark over here. Hello, comma, space, world. Okay? And it'll print out hello world. This /n over here is what we call an escape sequence. It's a special character meaning, hey, I want you to print out another line after you print this out. And I'll show you what it looks like with and without that. And then the semicolon is basically saying, I'm done with this statement. It essentially acts as a period. We just don't use a period in computer science a lot because we don't want to use a period to complete our sentences, because a lot of times we're going to be using periods for decimal point numbers or for function calls. So we want to use the semicolon to say this is the end of the statement. And it's very easy to hit because it's right by the JKL. right? So that is it. So to get out of this Vim program, I press escape, and then I do colon to do the commands, and then I just do WQ for write and quit. Okay, and so now there's a new file there, but I can't just run this C file. What I have to do, this is a C programming language, but the computer doesn't understand C. So instead what we use is a utility called a compiler to compile this C program, to basically translate it into code that the machine will understand. So what we do then is we write GCC, and G stands for the GNU C compiler. More on that. But it is the de facto utility we use to write stuff. And we type hello.c, the program we just wrote, and hit enter. Now it gives me what's called a warning, which means just that basically it's compiling and says, hey, there's something possibly there that might break. It's because I didn't put an int in front of main, but I'm just keeping it minimalistic right now. And that's fine. But if I look at my files, I have a hello C, and now I have a new file called a.out, which is the default name for anything that's been created by, any program that's been created by a C program. So if I run a.out by going, if I run a.out, now it says hello world. If I run it again, it will say hello world. That is the typical first program called hello world, which it will just print out the message hello world. So let's take a look, right? I can use Vim to open up my hello.c and look at the file, but let's take a look at that a.out file. So there's two types of files that exist on your computer. There are text files, and then there are binary files. Text files are things you can read using a text editor, and they're stored in just regular characters. So .txt files, but also source code files. The main kind of files, most of the files stored on your computer aren't those kinds of files. They are binary files, like video files. So for instance, this is a video file. So like these files over here, the FLV files that I'm using to that I use to record. But also the a.out file is a binary file. It is something that you need another program to be used, not something you can read. So, but let's open it up and try to read it. It's a bunch of gibberish right over here, and it will differ based what it looks like differs based on your computer. For instance, mine says, hey, it was built using a Linux utility because I'm running Linux. Specifically, I'm running a version of the GCC, and then says, this was built with the version of the GCC 8.3 on .0 on Ubuntu, which is the derivative that I use. And otherwise, it's just a bunch of gibberish. Let's see, though, if I can't find... Oh, down over there. So over there is a bunch of stuff we can read. Entry hello.c, which was the file name. But otherwise, it is just kind of... Oh, wait, here. Notice that in all these, like, little things over here, all these little caret at signs, you've got hello world in there. So it's unintelligible, completely unintelligible to pretty much everybody unless you're insane. I imagine there are some probably insane people who figured out how to read this. But note that I called them insane, so you know. So you're not expected to be able to read anything like this. This is something that's meant for your computer, and this is the commands your computer, my computer executes to figure out how to run those things. All right. So questions so far? Yes.
Yeah. How can I escape this thing?
Press the escape key. Okay, very careful. Press the escape key. Now press colon, so shift semicolon, all right? And that will bring out, and now you should have a field on the bottom. Type WQ for write write and quit. Yeah, it's often a joke that basically that if you want a random character generator, you just have to try to get somebody using 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 Vim to try to get out of it for the first time. So colon, and then I type right quit, and there you go. GCC hello.c. There you go. And now you can do /a.out. If anybody, well, let's see. Should have done a.out. Right. /a.out. There you go. Hello world. Were you able to get it running on your computer?
No.
Okay, let's see. To get out of that, you haven't gotten out of that yet. Right click like that.
Mm-hmm.
Enter GCC hello.
3 L's.
Yeah, oh. Let's see. And then it generated a warning /a.out to run that file. Hello world. Okay, so for you guys, I find that the using Nano instead of Vim might be a bit easier because it's much more like a standard text editor.
Okay.
Okay. Now, I don't know. I use Vim because. How about you? Were you able to get it running?
I was just using.
Or you can use an online text editor. Now, there's a lot of different tools for doing this, for building programs. I haven't used too many for C, but this is basically the primary tools in your that you have, which are compiler and a text editor. Typically, though, you can get a program that combines the two or has one. I use a program called Geany, which I'll be using in a bit. But one that's made by Microsoft, which is particularly good, because they made it open source, is Visual Studio Code, code.visualstudio.com, and this is a free program that you can download for your thing for it. And I'm not sure how to get it working on here, but I hear it's quite good. Sorry that I'm not too much help there, right? I haven't used Visual Studio Code most of the time, though. But I hear that this is quite good. I mean, I can go ahead and install it and see what happens there. But it's got things like code completion and other stuff. But really, one important thing you should know is that really the tool you use to write your program doesn't really matter. You find what's most comfortable to you, and you use it, right? Dr. LaFollette uses Vim because it's been around for forever, and it's extremely powerful, and it basically works on, and you can basically use it on any computer that ever existed, right? So it's already there. So code, right? So Visual Studio Code is already there. All right. So let's see. If I try to write a C program, it might come up with something for me. I don't know. I'm willing to take a couple minutes to figure this out or to see this in action. So new file, save the file as on my desktop as, so I'm doing it on my desktop as opposed to anywhere else, hello.c, and let's see what it says. And the C++ extension is recommended for this file. And so you can install that extension, and it will code browsing. So notice that it says C, C++. That's a distinction to make. There's C, which is this language, and then C++ is an extension of this language. If you know C, then you know a lot of the features of C++, which is a bit more of a bit of a bigger program. So edit. Sorry, it's a bit of a bigger programming language with more features. So settings, font size. Let's bump that up to, say 24. There we go. So let's go ahead and write that again, and let's see what happens. Include, see it already started that. std io.h, nice. And now I'm going to do int main to quash that error. And then notice that when I started typing this is pretty cool, put a curly brace there, it automatically put another curly brace because it knows that if you put one curly brace down, you'll want another one. print F, hello world /n, and then I need to put a semicolon over there, and let's go ahead and see, can I start debugging? See what happens with this. So what can I do with this? The thing is I have no idea how to start it for, how to get it to run at that point. Right? New terminal down here. So then I can write over here, and then down here, I can go over here and do cd to change the directory that I put it in. I put in my desktop, so no worries there. And then what I can do over here is I can do then gcc hello.c, and then I can run it down here, /a.out. So I can do it all in one window and just move back between these two things. Let's see. I'm sure there's another way a more automated way to do this, but I don't really mess with this programming. I haven't messed with this programming environment too much, so I don't really know too much about it. But it's extremely powerful tool here. It's very nice. Okay. For right now, I'm just going to use my tool, which is Geany. All right. So what else can we do? So let's go ahead and I'm going to go ahead and open that file that I just wrote, one of the hello files, and I'm going to start playing with it and show you what goes wrong when we miss a few things. So first, let me go ahead and edit this code. Preferences, interface, editor, Sierra Mono. Okay, and then let's make it nice and big. 24, select, okay. All right, so now all I have to do in this program, for me, is I have to hit F8 to compile it, and it will give me warnings down there, which you can't read because it's too small. Great. Okay, so message window. Right, make that size 20. It says, hey, there's an error, and all that does is just runs the GC. So me hitting a key to compile will automatically run that. And notice that it comes up with a red line over here saying it's a warning. So I'm going to fix that warning by putting int in. Compiled it correctly, then I hit F5 to run it. I think I do. Let's see. Build tools. Let's see. Execute. Oh, there we go. No. It's not found. So, and I'll still have to run it from the terminal. That's fine. Okay, so what happens if I don't do certain things? Like, for instance, if I leave out that /n. Okay, if I leave out that /n, really? Did it not compile? Sorry. GCC. If I don't put in the /, notice what happens. I get a hello world over here, and it doesn't go onto a new line. That /n is kind of important because what it does is that it moves it to the next line. The next thing is what happens if I leave out this semicolon and I try to compile it. It will tell me that I got a compilation failed. Now, errors are not like some errors in C are super hard to figure out, specifically when you get something called a seg fault or a segmentation fault. However, these kinds of errors, the errors that you'll be making at the beginning, are pretty easy to figure out if you read the error. This is also a very important point. You will make errors. This is a normal part of the process. Everybody makes errors. You are not stupid for making errors. You are not stupid for making errors that you can't figure out how to solve. Right? This is extremely normal. And this is why computer science is considered hard, because you're going to make mistakes and you have nobody to blame but yourself, but that's okay because everybody makes mistakes. It's that last part that you need to really be focused on. Everybody's going to make mistakes while writing code. And so here what it was saying was error expected a semicolon before the close curly brace token. And it's saying that it's in hello.c, then it says 425. Well, if you notice the line numbers over here, the error occurred on line 4, and it's saying that the error occurred on specifically character 25. So, saying here's where that error is, it wanted a semicolon first. And so, now computers are specific, now your compiler is very picky. If it doesn't work correctly, then it will, then what it's going to do is just throw a hissy fit at you, and it will just refuse to, it will just refuse to go. It will just refuse to go. Let's see. /E. Sorry, I'm just trying to make sure, see if I can't run this here. /hello not found. Oh, I can fix that pretty easily. Here we go. I'll just say that I want to do /a.out. And that I want it to, yeah, that's what's going on there. Okay. I see what you're doing there. Sorry, been a while since I did C programming, so I now know what's going on here. Awesome, great. I can do this now with a couple button presses. Okay, so now if I put in the semicolon and recompile, it will tell me, hey, whoops, missed the semicolon, right? It'll run, and F5, it works perfectly fine again. All right, but other than printing out cute messages, what can I do with the C programming language? Okay, so the first thing is that I can so the big thing about programming is that we can manipulate data, right? Which means that there's different kinds of types of data we can use. The two primary types you need to be aware of are integers and doubles. So what is an integer, first off? Like, for mathematics, anybody want to tell me what an integer is? Sorry?
Real number.
A real number, meaning it's... So first off, can they be positive and can they be negative as well as positive? Can integers in mathematics, not in computer science? Yes, they can. They can be positive and they can be negative. And they can be 0 as well, right? Right, so an integer, and what does it mean to be an integer? It's not going to be any real number, right? Because any real number would include things with what are real numbers include stuff with decimal points. What makes an integer an integer is that's a whole number, right? So an integer is a whole number. Now, this is where we get into our first problem with programming, which is that in mathematics, and that's basically we have all of infinite mathematics. What is the biggest integer? What is the biggest integer that exists? Well, just figure something out and add 1 to it, and then add 1 to that, right? There is no biggest number, right? So numbers can be infinitely large, which means that at some point they're going to take up, and you need space to store it, right? So right here, is a really big number. That's slow, so Control V. Right? Really, 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 really big. It is 10,000 digits long now at this point, right? I'm just holding Control C, Control V. So I'm just holding Control V at this point. I'm going to copy at this point and paste it and paste some more. Oh, and now my poor computer is complaining because it just does not want to deal with that, right? So, and you know, this is just me doing some text editing, and I've just crashed my program by just pasting, by trying to copy and paste 20,000 digits of 9. Okay? To illustrate that basically that computers have only so much of a capacity for dealing with numbers, right? There's only so much BS that it's willing to deal with. Oh, did it manage to do it? Okay. I'm not going to save it. I'm just going to close that part. So that was 81. So it really struggled there to deal with that, right? There's only so much space, right? Basically, using numbers takes up a certain amount of space. So in C, we limit the amount of space that can be used for numbers. So we'll see that basically that there's a certain amount of space that can be used for these numbers. Okay. So let's go ahead and see. So int. So the way we can create so what we can start doing is create variables like this. Int x. So this declares. So this is a statement that declares an integer called x. It declares that an integer called x exists. Okay. And what that means is that it is a digit that is a third, I believe, depending on the machine, is what we call a short integer. Sorry, not a short integer. This is just a regular integer, which is now some machines this is 16 bits long. Most machines, though, in modern days, this is a 32-bit number. Yes.
So how can I access to the file that I have created just now, the hello.c?
You would do vim hello.c, or you would go to your home directory in Finder. So in Finder, right, for me, because the way Linux works is that I go to home. Otherwise, for the file system on a Unix machine like a Mac, you'll want to go to your home folder, which should be located under /home/username. If you go to your Finder and just type in home and hit enter, it should pull up with that folder. And that's basically the top level where basically all your stuff, well, where your directories are located. Let me see. It's a bit of a pain because Macs don't really like that. Let's see.
There are a lot of messy things over here.
No, that's not. No, not here. This over here.
Oh.
Oh, Spotlight. Do home. There. Yeah. Yeah. So go to the Spotlight, hit home, and I think that should work. Oh no, that's a program. Interesting. Yeah. Yeah. No. So with Macs, it's a bit of a pain because you want to get into the folder above this level.
Oh yeah, I see what you're saying.
So if you go into, yes, and I always forget how to do it on a Mac because again I don't use a Mac so often.
That's okay. I can just find it out.
Let's see, /home / really? Why does it? Hold on one second. Open my home folder.
Here's that folder.
There you go. I don't know why that works. I don't know why it makes it so hard, but that's your home folder. But there it is. And if you double click it, it should open up an Xcode or something. All right. So, let's see. I'll go ahead and let's go ahead and actually I'll write a nice big program up for you guys, which will show you guys some things. But first, let's just do in x. Now, I can give x a value like 5, right? So there's two statements here that I just did. A declaration and an initialization statement, which says, hey, I've created a variable called int x, and I've given x the value of 5. So now I can go into this print line statement and say printf, and the way of printing stuff, I do %d. Let me go ahead and say, actually, x is %d. And then I say, comma, x. So, and this comma is out, and the x are outside the quotation marks. So what this is saying basically that this is a placeholder for a decimal number. This is a placeholder for some digit over here. And then it's saying, okay, I'm going to look at my arguments, at what comes after a bunch of commas to put in here. And so it says x is for the first one, so I compile it, and I run it. And it, come on. I said to compile it. Okay. Is it not? Sorry, again, it's not. Okay. X is 5. There we go. So it comes out with x is 5. So you can create digits like this. So let me go ahead and look at a more robust program. Let's go ahead and write. So I'm going to create a new file. I'm going to create something called temp.c. And what this is going to do, what we're going to write here is a standard temperature converter. It's a pretty standard first program, strong program to write. And there's a lot of things that are going to go on here, which kind of gives you an idea of what we can do. So standard include our input output so that we can read to the user. Int main. And now let's go ahead and say int Fahrenheit, comma Celsius, which I'll just Celsius. Right, and so I've declared two variables there. You can declare as many variables as you want. For instance, I could create int A, B, C. I can do as many variables as I want over there. Also, variables can have whatever name, pretty much whatever name you want. There's a couple of rules that you need to follow for them, but so long as you make them basically with lowercase letters, that's all cool. Things that don't work, starting with a digit, for instance, that won't work. Let's see, that's pretty much the biggest rule there is. You can't start a variable with a digit. It can't have a space in it. Is another thing, and that you can only use characters that are alphanumeric. So in other words, any letter, capital or lowercase, will work. Like this. Serious variable, right? This is a valid name, and the last thing that you can use is what's called an underscore. So any alphanumeric character plus an underscore is valid in C. Other programming languages allow you to use whatever the heck you want as variable names, which can lead to some interesting issues. But also note that C is probably not Unicode compliant, which means that basically you're limited to English characters for stuff. All right, so we've declared two variables of Fahrenheit and Celsius, and what we're going to do is say, let's go ahead and take the current temperature in Fahrenheit. Int Fahrenheit is, sorry, we only do int once. Int is used to declare a new variable. It's what, like 47 degrees today, 49? So we'll put down 49. So let's go ahead and figure out how to convert that into Celsius. So Celsius is equal to, and this will go over a lot of things all at once. 5 times, let's see, it should be basically, it's like, yeah, it's Fahrenheit minus 32 times 5/9, right? So I'm going to do 5 times, and I'm going to do this for a reason in this order. 5 times Fahrenheit minus 32 divided by 9, which is totally appropriate due to order of operations. And now we'll just do printf the temperature is 50, sorry, is, let's see, digit degrees Fahrenheit /n, or actually I'll put the /n afterwards, right? I think I'm allowed to change that. Or, and that's going to create a new line there, or 9. So if you're using Vim, like using your standard copy paste don't work in Vim or Nano, because guess what? It existed prior to the standardization of copy paste, Control X or Command X and Control. So we'll see. Or let's see, digit degrees Celsius. And so now we put, so it's quite a long line, but I'm going to put then comma Fahrenheit, because that's going to be the first digit, and Celsius, which is going to be the second digit. Okay. Oh, yep, there's a comma there. I'm going to go ahead and turn on line wrapping so that we can see this. Right, this is all one line. So we compile this again, and then I'm going to run this. So again, me hitting this button automatically just ran GCC temp, and it had these other arguments in there. And now I run it, and it says the temperature is 49 degrees Fahrenheit, or 9 degrees Celsius. So first things first, we declared a two variables. So let's talk about these equal signs over here, which I've been saying equal sign. In reality, this is actually not the equality operator that you have in mathematics. We're not saying one side is equal to another. What goes on here is actually far more interesting. This is we use the equal sign here for what's called the assignment operation, which says we are going to take the thing on the right and we are going to store it in the thing on the left. So we're going to take the 49 on the right and store it in Fahrenheit. We're going to take specifically the expression, the value that yields from the expression on the right, and store it in the variable on the left. You can only do it in this order. You can only have an expression on the right. I'll get into what an expression is in a second. And you can only have a variable on the left. Variables, same as it would be a variable in mathematics. The only thing here is that with ints, we specifically need it to be whole numbers, right? If I try to do this as like 49.8 degrees or something like that, it's gonna cut off that 0.8, right? Integers only store whole numbers. They don't store, they don't store the any decimal points. Now, notice over here that that we actually have a mathematical expression over here on this side of things. Celsius is equal to 5 times Fahrenheit minus 32 divided by 9. Notice that we can put a variable over here on the right side. Now, if you remember your order of operations from mathematics, which is why there's these math prerequisites, because we do rely on you knowing your order of operations, then the first thing you do is that you do what's inside the parentheses first, right? So the same order of operations that exist in mathematics are what exists here. So you do Fahrenheit minus 32, which would be 49 minus 32, which is 17 times 5, which is some big number. Let's see, what's 50 times, it's 50 plus 35, right? 85, right? 85. And then 85 divided by 9. Now, I don't know about you, but 9 degrees Celsius isn't 85 divided by 9, is it? Right? What is 85 divided by 9? It's
9.7.
It's like 9 and a bit, right? But here's the thing. Remember, all we're dealing with here are integers, right? We're just dealing with integers. So remember what happened when I just put in 49.5 over here? And it just simply ran with it, except it threw out the half that I put in. Same thing goes on over here. If we do division in, whenever we do division in C, so say we do 6 divided by 5 in C, right? In real life, this would be, equal to either 1 1/5, right? Or it would be equal to, 6/5, or it would be equal to 1.2, right? But in C programming, and in most computer programming languages, if we're just dealing with integers, then we only get an integer as a result. 2 integers yield an integer, which means we get to go back to like the 4th grade and be lazy about this, which is that we only care about the quotient. The quotient, right? Remember your quotient and your remainder in 4th grade? Well, all we care about is the quotient in this case. We say the quotient is 1, right? So we just simply throw out the decimal points or the fractional bit that would come after it. Okay? So same thing with 7 divided by 5, right? So here's one for you. So in other words, what would 97 divided by 10 be in C? It'd be 9, right? Okay. So this actually gives us something very interesting in C. You have your 4 standard operations. We have plus to add 2 numbers together. We have minus to subtract 2 numbers. We have our times, which we use a star for, and we have divides, which we use a single slash for. Right? These are your standard 4 operations, or your binary operators, as they're called. But because it's not confusing enough, we're just going to add one more. We have one more special one that we really only ever use in computer science or in advanced mathematics. And it's a lot more of an advanced operation than it seems, but for right now, we're just going to use it. We're going to use it basically in a very easy fashion. So remember, this would be in 4th grade mathematics. This would be 97 would be 97 divided by 10 would be 9 remainder 10, right? Sorry, 9 remainder, 7. Right? That's how many's left over. 97 divided by 10, you have 7 left over. Everybody remember that kind of? Digging back to those childhood memories? You know. So you have a remainder of 7. That's how much is left over. So doing 97 divided by 10 gives you the quotient. But this operation, this percentage sign, is called modulo. And that gives you the remainder. So if we did 97 mod 10, that would give us the remainder, what's left over after we divide by 10. It would give us 7 over here. Okay, so you use this to get the quotient, you use this to get the remainder. And this is if we're dealing with integers specifically. With decimal numbers, it's a different story. But the modulo is extremely powerful. We typically use it for 2 purposes. The first purpose we use it is that we can, when we learn about if statements, we can use it to test if things are even or if things are divisible with other numbers. It's very powerful like that. And the other thing we can use it to do is to tear off the last digit of a number. Right? Notice that if we were to mod by 7 to get mod by 10, we get the last digit. We get 7, which is the remainder. It's actually a very powerful operation. But anyway, let's continue with this. All right, so we've got this mathematical expression. It yielded 9, and it stored it in Celsius. Then we go to the printf statement, which says the temperature is d degrees Fahrenheit or d degrees Celsius. And so then we listed Fahrenheit and Celsius over here. And this went over here to the first one, and the second one went to the second d. Fahrenheit came first only because I said Fahrenheit came first. Right? If I did Celsius, Celsius, right? If I just kind of was blindly typing like that, which happens all the time, it's going to give me 9 degrees Fahrenheit or 9 degrees Celsius. It's going to do exactly what I tell it to do. It doesn't magically know that Fahrenheit comes first. This is just a string. It's gibberish to the computer. All it knows is that you want to put in a number here and a number here. Okay. So now typically though when we're writing stuff, you might want to be able to remind yourself what the heck you're doing in here, right? You want to leave some notes for yourself. So let me go and not just because you're learning for the first time, but because you'll write something and then if you don't have notes, you're going to forget what the heck you wrote it for, or what you were doing there, and then it's gibberish. So we have this thing called comments, which are represented by 2 slashes over here. And so let's go ahead and see. Fahrenheit to Celsius converter. Now what's our comments? Notice that it came up in nice and red over here. Well, comments are this special field of text. The computer, if the compiler sees 2 slashes, 2 forward slashes like this, it knows to ignore everything it sees after that on that line. So for instance, here I'll put after int main, and then I'll just hit my keyboard a bunch of times, right? So // I hit my keyboard a lot. Come on. Some reason on Control S. Okay, so now right, and notice that basically it doesn't change how my program works. Well, it doesn't crash my program. It doesn't throw any errors when I try to compile it. Make sense so far? So we've got ourselves. So there are ways to basically leave ourselves notes. Right? And so we can leave notes for ourselves. It ignores everything after the 2 slashes. Well, if I need more than 2 lines, then you can use what's called a multi-line comment. And the way that works is that basically if you do /*, then the computer will ignore everything until it sees a //. So everything between here will be between those will be ignored. All right. All right, so let's go ahead and let's see. Yeah, just jumps you right into it, doesn't it? All right. So before I move on, any specific questions about this? Please. If you have a question, I guarantee everybody else is thinking it.
I'm still confused how to escape this.
A Vim? Yeah, I
So
suggest
it
using.
does escape.
I suggest using a online text editor or a different or Visual Studio Code for right now. But if you want to escape,
I can get on here, but what's it?
Q.
That's it. With presented.
Yep. And that will quit. So the Q is for quit. The R is for the W is for saving. All right. If you you downloaded Geany, I guess?
Mhm.
Yeah. So to run it, I think you want to use like F9 to build it, and then F5 to run it.
Okay.
Okay. Or you can just simply go over here and hit the build button, and that will. And what this command does is says GCC. This says generate all warnings, and then the .o means that basically that when we compile, rather than compiling it to a.out, it's going to compile it to a temp.c to temp. That's why that. And then the F5 command or the run command, or the execute command over here looks for a program with the same name as the program you're trying to run. Okay, it works for if you're if you're doing single files right now. All right, so let's go ahead and I'm going to go ahead and write and start another file over here. It's going to look a lot like the other one we did, but I want to show. So this one is going to be called temp table. Temp. Why is it flashing like that? I'm sorry about that, by the way. I didn't realize. Really, that is going to get really hideously annoying. Temp table.c. Okay, temp table.c. So first things we're going to do again is we are going to include stdio.h. Just going to standard input output. There's no semicolon need for that. Int main. And let me go ahead and describe what we're going to be doing here. We are going to be doing a print Fahrenheit to Celsius table. For (0, 20 to 300). So here I'm going to print multiple values. Now, here's the thing, right? I could print multiple values just by simply saying, hey, Fahrenheit is, by doing a lot of copying and pasting. I could say, hey, if I want to figure out the Fahrenheit. So don't do what I'm just about to do. I'm just kind of showing you basically, I'm just trying to show you kind of, so don't copy this because I'm going to delete it pretty much immediately, right? If I want to show basically what the temperatures are, I could say, hey, Fahrenheit is 0, right? And then I could say, hey, Fahrenheit is 20, and then Fahrenheit is 40, and then Fahrenheit is 60, and then the Fahrenheit is 80, and then if I were to compile this and run it, right, 0 is 17 degrees Celsius, 20 is 6 degrees Celsius, 40 is 4 degrees, 60 is 15, 80 is 26, right? That's a lot of copying and pasting to do over there. That's tedious and boring and repetitive. And if there's one thing programmers learn to hate, it's being repetitive. And having to copy paste a lot. So instead what we can do is that we can automate this process using a mechanism called a loop. So what we'll do is that we will write int main over here. So we've got our Fahrenheit and Celsius just like we normally have, but I'm going to create something called int lower, upper, and step. And what I'm going to say is that these are the bounds that I want my program to run. So I want to start from the lower bound of 0 degrees and go to an upper bound of 300 degrees. And I want to go up to by a step size of 20. So lower bound for temperatures, upper bound for temps. Okay. And then we're going to start out by saying Fahrenheit with a very simple expression over here. Fahrenheit is equal to lower. In other words, Fahrenheit is going to start at what? What is Fahrenheit's initial value here? Well, first thing we do is we look at lower. What is lower's value? 0. So we take 0 and we copy it into Fahrenheit. So note that basically lower and Fahrenheit, they both are 0, but they're not the same 0. They both have a copy of 0 in them. Okay? We're not like saying that Fahrenheit and lower are the same thing, right? They don't have the same number. If I increase one, the other one doesn't increase. What we did is that we yield 0 out of this. We figure out what is lower. It is 0. And then we take that value and put it in here. Right? So now, look at this. Well, so now we're going to do ourselves a while statement. So over here, I'm going to say while. And I'll explain this. Right? I don't expect you to understand all this. This might even be a bit faster than Dr. La Follette wants, but you know what? I'm going to trust the book. While Fahrenheit, and then I put a less than sign equal, and then an equal sign, which means less than or equal to upper. While Fahrenheit is less than or equal to upper, and then I put another pair of curly braces over here. Okay? So I have another pair of curly braces because what this while loop does is that it will repeat whatever is in between its curly braces so long as the expression inside of it is true. Fahrenheit is 0, right? Upper is 300. Is 0 less than or equal to 300? Yes, it is. So this loop will run. Right? It's actually, so long as I don't put anything in here, it will run forever with what we call an infinite loop. So Celsius is equal to 5 times Fahrenheit minus 32 divided by 9. Okay. Now let's just pause here for a second because you might be wondering why. I'm going to go back here for a second. Don't bother. You don't have to change anything. I'm just going to show you guys something as an example. Just why am I doing it in, if it's, Fahrenheit minus 32 times 5/9, why am I doing it in this order? Why don't I do it like this? Fahrenheit times 5 divided by 9. Why don't I do it like that? That seems more intuitive. And the answer has to do with order of operations. The way order of operation work is that we go from left to right. So we do whatever in the parentheses first. This yields some number. Okay? And then we multiply times 5, and then we divide by 9. Okay? Or, well, the thing is that if the temperature is too low, we can actually get an interesting error, or an interesting bug, rather, because it doesn't crash our program, which is better shown is that by if I instead do it like this. What if I do 5 divided by 9 times Fahrenheit minus 32? Right, same expression. So again, what is 5 divided by 9? In real life, that's a fractional value, right? That's something that's less than 1, but greater than 0. But in C, 5 divided by 9 yields what? 0. So our temperature would always be 0 degrees. So no matter what Fahrenheit we entered, if we did it with this expression, it would be 0 degrees. That's the danger of when you do division, right? 5 divided by 9, this yields 0. So by doing it in this order, this weird order, we are ensuring that our number is probably bigger than 9. But this ensures that basically we don't get a bug because of that. Anyway, so we calculate the Celsius. And what we're going to do is that we're going to print F. We're going to do a printf statement. Printf. Let's see. Yeah. So this one looks a bit weird. So I did %d / t %d. So digit over here. And remember, /n gives us a new line. /t is short for tab. So in other words, it puts a tab in between them. So it's %d / t %d / n for a new line. So we have 2 digits in here. So I'll do Fahrenheit and Celsius. And I swear it looks a lot cleaner when in our output than it does over here. And now finally, possibly the most challenging statement that one of the 2 most challenging statements you're going to have all semester. Might as well get it out of the way on the first day. Fahrenheit is equal to Fahrenheit plus step. And this statement over here is the most, it will probably, Dr. LaFollette will probably repeat it, but this is the most challenging statement basically of your first couple weeks, or whatever amounts to the first couple weeks in your standard course. So it is Fahrenheit is equal to Fahrenheit plus step, which in mathematics, right, that doesn't really make too much sense. Like that's me writing over here in math, like x is equal to x plus 1, right? In math, that doesn't really make sense, right? But remember, that's an equality operation in mathematics. It says that the left side and the right side have the same value, right? In mathematics. But in computer science, we use this equal sign differently. We use this equal sign to say the value on the left, the value on the left gets the value on the right. In older languages, it actually, and by older, I mean older than like 1972. It used to be colon equal to basically do an assignment statement to try to differentiate the fact that basically an assignment is not equality, right? To say, now why colon equal? I hypothesize it's because what we really want is actually this arrow symbol. And in fact, when we write pseudocode a lot of the time, in a lot of mathematics papers, you would do an assignment like this. You would be writing x gets the value of 5, right? This makes sense? X, take 5, store it in x, okay? But if I try to do that on a keyboard, right, I'd be using a less than sign and then an arrow like that, which would be read as what? X is less than -5. So can't use it like that. Okay, can I use a double equal sign? That reads as 5 is less than or equal to 5. Or x is less than or equal to 5. So you can't use that. So I hypothesized that they eventually just decided to do that, which eventually just got shortened to the equal sign. So this is saying compute the value on. So if we do the following, just this small block of code I'll write on the board. X is x. So int x is equal to 5. X is equal to x plus 1. Print f. Yeah, it will be 6, but I'm doing it proper, so to speak. What is x? What will be printed out? And the idea here is that x is 5. X is equal to x plus 1. What that does is that this takes the value on the right and stores it on the left. What is the value on the right? It is 5 plus 1, which is 6. So we store 6 now, overriding the previous value of 5. So that overwrites the previous value by 5. You can think of this statement as increase x by 1. Right? X is equal to x plus 1. That's increasing x by 1. So over here, what we're doing is that we're taking Fahrenheit and adding step to it. 0 plus 20. And that's going to store 20 in Fahrenheit. Okay? And this statement will continue doing so while Fahrenheit is less than or equal to upper. So if we run this now and compile it. Oh, sorry, it's running the wrong one. F9. We get this table over here. 0 is 17, 20 is negative 6, 4 is 40, 6. So notice it goes all the way up to 300. Why does it go up to 300? Because we specified that upper is 300. Low, it's going to start. Why does it start at 0? Because we specified that we're starting at 0. I could change this, negative 200 to positive 400. Right? And I can compile it again and run it. Negative 128, sorry, negative 2, and so now by changing those bounds, changing those two variables, I get a much bigger table. Okay? So let me go ahead and actually just shorten this a bit because I'm about to run through it by hand, so to speak. And so it'll be easier. So here I've changed the values to be lower is 0, upper is 100, and we're going to go by the 20s. So Fahrenheit. So this first step, what this says is that we are going to put 0. We are going to put 0 into Fahrenheit. Okay. So while Fahrenheit is less than upper. So while 0 is less than what is upper? 100, right? While 0 is less than 100. So the while statement will run so long as this expression is true. Now this is a true-false expression, also known as a Boolean expression, named after a mathematician who spent too many years of his life working on truth-false statements, George Boole. Okay? Celsius. So now what we do is that we do the computation to convert Fahrenheit into Celsius and store it in Celsius. Then we print out this Fahrenheit value and its respective Celsius value. And then we do Fahrenheit is equal to Fahrenheit plus step. It's saying that basically we are going to store, inside of Fahrenheit, we are going to store the value we grab from Fahrenheit. So what is Fahrenheit value? It is 0, and we're going to add 20 to it. Right? So that means we take 20, take 0, add 20 to it, and we store it in Fahrenheit. Which means that now that Fahrenheit gets the value of 20. So now we ask ourselves, well, is 20 less than 0? Sorry, is 20 less than 100? Less than or equal to? And it is. So we take Celsius, we do the conversion for 20 degrees, say 20 degrees is this much Celsius, and then we say, okay, we are going to store inside of Fahrenheit the value inside Fahrenheit plus 20. Fahrenheit is equal to Fahrenheit plus 20, which means that we are going to increase its value by 20, so we get 40. Okay, so now we jump back up to the beginning of the while loop and ask, okay, so what is Fahrenheit? It's 40. Is that less than or equal to 100? Yes, it is. And then we do the same thing again, where we can get its Celsius value for 40, print it out, and then increase it by 20. Get the value from Fahrenheit, it's 40, add 20 to it, it becomes 60. Then we ask, is 60 less than 100? And then we ask, is 80 less than 100? And then we do, is 100 less than or equal to 100? It's not less than, but 100 is equal to 100, right? And then, so we'll figure out what the Celsius value is for 100, print out the two values, the Fahrenheit value of 100 and the Celsius value of whatever that is. And then it will say Fahrenheit is equal to Fahrenheit plus step. 100 is, so we're going to store inside of Fahrenheit 100 plus 20, right? Its current value plus 20. And then we go up to back to the beginning of the while loop, and we ask ourselves, is 120 less than or equal to 100? It's not. That's a false statement. So we just, at that point, then we skip what's inside the curly braces and go afterwards. So instead, and to show that, I can actually just show print F. I wish it would stop flashing whenever I typed. Done. Sorry about that. That hasn't happened on any other computer. So it runs, and it runs done. Runs, and then we print out done after it's done, after we went through all our loops. Any questions about this concept? But right now we're just doing a broad overview. We haven't really gotten into, we've only learned about integers, and now I'm talking about these Boolean things. We haven't even talked about how to do floating point numbers. Yeah?
What does /t mean?
The /t means tab, right? So let's go ahead and experiment over here. If I put a space between these two guys, okay, and compile and run, right, I get 0, -17, 26, right, and I get a single space in between all these digits. But that's pretty, but that doesn't line up that great. What a tab does is that basically that it helps over there by spacing things out. And by putting a tab over there, it helps even things out a bit, because, and it puts in the literal tab symbol as though you had typed in tab. And the reason we use a symbol is a lot of the times is that various computers and various programs have different interpretations on how big a tab should be. So, for instance, one program might think a tab is 4 spaces long, whereas another might think it's 8 spaces long. And a typesetter might think a tab is 4.5 spaces long. It gets ugly. Another question. All right. So, let's see. When does this class go to? 10:30? 10:30. So, I'll use the time to talk about other different types that we have here. So, before I dismiss you. So, types.c include std IO standard input output.h. So this one is not going to be a particularly strenuous program. Int main. What instead I'm going to go over are basically the different types you use for C. And I'm sure Dr. LaFollette will go over basically helping you get set up. But the lab computers here you should be able to program in C on them. But Dr. LaFollette will run the labs. First lab isn't here today. Again, we didn't want to waste too much of your time. We didn't want to waste a lot of time for you guys, by not having your first lecture. So, let's go ahead and talk about your different types. So I talked about having integers like this, right? And you can put a full number in here. Now, what's important to know is that these are 32-bit numbers, okay? So this is the number I just put in is 10 million, 100 million, 1, 2, 3, 100 million. All right, so I just put in 100 million there. Now, a 32-bit number means that it can have 32 binary digits. 100 million is 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal digits, right? Now, 32 bits doesn't really mean too much to you right now, but in practice, that means that it can hold a value of, we use 1 bit to determine whether the number is positive or negative, and then we use the remaining others for values. So we can store a maximum of 2 to the 31st power minus 1, which is slightly over 2 billion. Don't have to know the exact number, or I don't care about the exact number. Dr. LaFollette might, and he will give it to you if he does. But what it means is that this is the biggest that a number can get, and the smallest that an integer can hold is 2 to the 31st. In other words, your computer can't count past these numbers without doing something special, like using something called a long, which has 64 bits. But we're not going to get into that. So practically what happens what if I try to do something like this? So printf /n x. What happens if I try to print this sucker over here? Right? It's no problems printing that. But what happens if I try to print times 2? Let's go ahead and see if this notation works. Doing x times 2. No worries there. 200 million. So if I did by times 20, this would be 2 billion. Okay, what if I do times 25? I get a negative number. And this is what's called integer overflow, where the number becomes so big that basically, because of the way mathematics work for holding these numbers, it wraps around. How many of you have played the game Civilization? Sid Meier's Civilization. This is a tangent that is relevant, I swear. Who here has played that game, Civilization? That's the disadvantage of a small class. So yeah, Civ 5 or Civ 6. Yeah, Civ 6. Yeah. So Civilization's this fun game. Sid Meier's Civilization is the official name. It's a computer game, very popular. Where basically you take basically a country and you build up you build up your borders, your military, and try to take it from basically the Stone Age to the modern era and beyond, right? And try to achieve victory in some way, either by conquering all your people or conquering all the neighbors, or sending off something to Alpha Centauri, or having everybody elect you world leader, right? Some way of performing victory. So Civilization is obviously a very popular series if they're able to do 6 of them, right? And Civ 2, their sequel, was really interesting. Now typically they take typically they take a famous leader, right, from every country and make them the leader of the country, right? So for America, it's either Lincoln or Washington, right? Typically, most recent game it's Teddy Roosevelt. Okay, now for India, it's always the same leader. Who is the most famous leader of India? Mahatma Gandhi, right? Mahatma Gandhi. And so they always try to focus the civilization to be basically accurate and reflect the historical leader. For instance, if you run up against the Huns, led by Attila the Hun, right, you're pretty much guaranteed you're going to get into a war with him, because Attila the Hun is not, and Genghis Khan, they're not known for their peace-loving ways, right? On the other hand, Is it these things that are blocking me? Okay. On the other hand, Gandhi is known very much for being a peaceful person, right? So imagine your shock in Civilization 2 when you're playing against Gandhi and you hit the modern era, and then suddenly Gandhi is basically sending you messages like this. Civ 2 Gandhi, and he's sending you, he sends them at you. Very well, we will mobilize our armies for war. You will pay for your foolish pride. Also, he'll say, greetings from Mahatma Gandhi, rule the king of the Indians. Our words are backed with nuclear weapons, right? Threatening you to let you know that he is going to nuke the heck out of you if he displeases you. He just starts suddenly producing tanks left and right. Okay, and why is Gandhi such an... So that's a great title for that. Okay, so the reason is because in Civilization, they use a byte field, 8 bits, something from 0 to 255, no negatives, okay? That's important, no negatives for basically various things like aggression. Gandhi has an aggression rating of 0. But once you get into the modern era, what would happen is that basically Gandhi would adopt democracy as his form of government. And any AI that adopts democracy as their form of government, their aggression rating goes down by 1. Okay? Gandhi has an aggression rating of 0. Okay? In other words, it looks like this. 0 bits. Sorry, 8 bits of 0. You subtract 1 from them, and because of the way subtraction works, essentially what happens is that basically that flips all the bits, and he gets an aggression rating of this much in Civilization as soon as he adopts democracy, which is 255 out of 10. This is because of an overflow error, or underflow in this case, where basically we subtracted too much and it flipped back around. So that's why, this error of basically having a number that's too big, is why basically this overflow error is why you get bugs like that. And this is because of the way that basically binary addition works. Right? It's actually fairly simple to add numbers in binary. So this number is 1, 2, 8. So this is 11. 11 plus 7 in binary would be 4 plus 3. Right? So how do I add numbers like this in binary? So 1 plus 1 is typically 2, but the only digits you can have in binary are 1 and 0, right? 1 plus 1 is 2. So instead we put, and 2 in binary is 0, 1. Okay? Why is that? Well, in decimal numbers, you've got, like this one, 156. This is actually 1 times 100 plus 5 times 10 plus 6 times 1, or more mathematically correct, it is 1 times 10 to the second power plus 5 times 10 to the first power plus 6 times 10 to the 0th power. 0th power always being 1, right? Here, in binary, this is 1 times 2 to the 3rd power plus 0 times 2 squared plus 1 times 2 to the first power plus 1 times 2 to the 0th power, which is 8 plus 2 plus 1. I've got a PDF of this that I can share with you if you're interested. But anyway, this makes this particularly easy to do addition. So 1 plus 1 is 0, carry the 1. This is 1 plus 1 plus 1, which means it's 1, carry a 1, which is 1 plus 1, which is 0, carry the 1. 1 plus 1 is 0, carry the 1. And now, because I'm on a board, I can just simply add a 1 in front of here and say that 11 plus 7 is equal to, this was an 8, so 16 plus 2. It's equal to 18. But on a computer, I don't have that space necessarily, right? If I'm just adding 4-bit numbers and I get a 5-bit number, that last bit just gets thrown out. And that's why we get overflow. And why does it go into the negatives? Because we use this first bit in something called, what is it? For some reason, 2's complement, that's it. We use 2's complement notation for negative numbers, which you don't need to know about. Okay, so anyway, so that's the limit of decimal numbers. However, if you instead use a long over here instead of an integer, you'll use 64 bits, which is a really big number. And over here you would just put LD for a long digit. And now you can print out something that's much bigger. But most of the time you never need to use longs. You just can use X. So I use ints, and that's perfectly fine. Okay, the other type that you use, so we have our integers, which have no decimal points. The other type is a float, which are 32-bit floating point numbers. Float F is equal to 3.5. So what does a floating point number do? A floating point number, which we'll put out percentage F over here, F for the floating point number, will print out decimal points. It will handle that. Oh, when you compile it. Unused variable X. Ah, right. Doesn't like the fact that I created a variable and I'm not using it. That's why. So, 9. Oh, and I forgot my semicolon. Right? I told you. Been programming for years and I still make errors like that. You will too. Every programmer will. So, 3.5000 comes up. It's a floating point number. F is used for floating point numbers. And floating point numbers, again, these are numbers that have decimals in them, right? And you can have as many as you need up to a certain point. Generally, it's more than you need for like significant figures, but again, it's 32. Now, you do get some oddities with floating point numbers, but these things do work kind of the way you would think they would. 1 divided by, so let's say 1.0 divided by 3.0. Okay, so floating point F is equal to 1.0 divided by 3.0. Okay, and again, the float is for floating point. And it gives you 0.333333. Make sense? Right? 1 divided by 3. You get, technically it's an infinite number of 3's, but I don't have, again, the computer space, the memory to store an infinite number of 3's. And also, remember, this is actually a decimal number being converted into a binary number, which is being then converted back into a decimal number for you, which can lead to some actual ambiguities here, or some weirdness. Let's see if this works on a float. So that will work there just fine. Typically, though, you don't use floats because you can only hold 6 decimal places. Typically, instead, we use something called doubles, which are double the length of a float, hence why they're called doubles. So double D is equal to 3.5 or 3.4 or 3.1415926. Compile. Double, oh right, unused variable, and didn't put in S. I've been programming a lot in Python, which means I don't need to use semicolons a lot, so hence why I've been missing out on those. By default, the F over here, you're only going to have 6 decimal places. So by default, it will have only 6 decimal places. But it's quite. But anyway, you can use floating point numbers over here using F, and this is good if you need to use halves or something. There's also another type that we use over here. I want to introduce one more type before you go, which is, and I'll let Dr. LaFollette pick up here, which is the char, which uses single quotation, and we use that to represent a single letter. And I think that's a good stopping point and a good place to pick up. Anyway, I have a class, in 20 minutes to get to. So unfortunately, I won't be able to stick around for questions, but if you do have questions, you can email me or Dr. LaFollette. I suppose I should put his email up. So if you give me a second, I'll get that for you.